Welcome you all. In this session, we are going to discuss a per unit impedance diagram and per unit reactance diagram. Outcome: after successful completion of the session, the student would able to draw the impedance diagram and reactance diagram for the given power system. Per unit impedance diagram for power system. The impedance diagram is the equivalent circuit of power system in which the various components of power system are represented by their approximate or simplified equivalent circuit. So the impedance diagram on a single phase basis for under balanced condition can easily drawn from a single line diagram. The following assumptions are made to draw the impedance diagram. Usually, the assumptions made are the neutral reactants are neglected, the shunt branches in equivalent circuit of transformers are neglected, the resistance are neglected, all static loads are neglected, and the capacitance of transmission lines are neglected. So on neglecting these values, we used to draw. This is the basic assumptions we made. So I have listed out the assumptions that are made during in order to plot the impedance diagram. So the first one is the single phase transformer equivalent as shown as idle. The impedance on appropriate side, the LV and HV, low voltage and high voltage. The magnetizing reactance of transformers are negligible. The generator are represented as constant voltage source with series resistor and or reactance. The transmission line are approximated by their equivalent model. The load are assumed to be passive and they are represented by series branch of resistors or reactants. Since the balance conditions are assumed, the neutral grounding impedance do not appear in the impedance diagram. In impedance diagram, each component is represented by its equivalent circuit. Example, the synchronous generated at the generating station by voltage source in series with resistance and reactance, the transformer by a nominal pi equivalent circuit, and the load is assumed to be passive and is represented by resistive and inductive reactance in series. Neutral earthing impedance does not appear in the diagram as balanced condition is assumed. So here you have drawn an impedance diagram for a power system. So here you can see, so the major parts of a power system are the generation, transmission and the distribution. So in the generation part, here you can see the generator you have. Next you have a transformer from the generating station in order to step up. Then the transmission is done. In here this is transmission line. Then after in the distribution side you have a distribution transformer in order to step down, and later it has need to be connected to the load center and the motor. So this is how the impedance diagram is plotted for a given power system. Next, the reactance diagram. So the reactance diagram is the simplified equivalent circuit of power system in which the various components are represented by their reactance. For the previous impedance diagram by their equivalent circuit, and here it is with their reactance. So if we plot a diagram with its reactance, we call it as the reactance diagram. So the procedure to draw the reactance diagram are as follows. All the steps involved are: first, choose a common base kV and base MVA for the either session. Divide the system into various sessions of different voltage levels. Base MVA will be remaining the same for all the sessions of the system. Find out the base kV for each and every session by using the relationship base kV on low tension side divided by the base kV on high tension side is equal to the voltage rating of low tension side divided by the voltage rating of high tension side. and base value of high tension side divided by base value of low tension side is equal to voltage rating of high tension side divided by voltage rating on low tension side. So with this relation we can find out the base kV. If the actual value of component is given, then the per unit value is given by Z per unit is equal to Z actual by base, and ZB is equal to KVB square divided by MBAB. So here I have listed out the steps involved for the reactor. So the next here you can see the reactance diagram. So for here we are not going to plot the equivalent circuit. We'll be neglecting certain terms and we'll be plotting only the reactance for that. So here for generator you have this generator EMF and the reactance. For transformer reactance, transmission line reactance, and the transformer 2 reactance followed by the load reactance. So this is how the reactance diagram will be. So here you can see a illustration with a generating station with two transformers, and you have a load center M. So here for generator, as I told already, with EMF with reactance. For transformer, that is XG1, and the transmission line reactance is XJ50 ohm, and transformer 2 reactance is XT2, and the load reactance is XM with EMF EM. So on total you have the Xg, that is the reactance of generator, Xt1 the reactance of transformer 1, Xj50 is the transmission line reactance, and next we have the transformer 2 reactance followed by the load reactance. Thank you.